So if you want to follow along on your computers, um, if you go to Brightspace under stimulus programming, you can grab the faces_short.zip. And this is quick to download, and it's just got 6 face images in there. You can see them. And these are kind of standard for face processing experiments. They've had the hair removed because hair is sort of a distinctive feature and it's not related to the face, so they want to just sort of isolate the face from other kinds of information. The other thing you'll notice is that the faces, like that one's kind of brighter, that one's a little darker. And if you look at the background brightness is actually different between these images as well. Some it's a darker gray, some it's a lighter gray. Anybody want to guess why that's actually not a bad thing?
Balance out.
Exactly, right. So what's been done is the luminance of the entire image has been matched across all the images. And so for the face where it's brighter, maybe you need a darker background, or something like that. It's maybe not entirely obvious from one picture to the other, but using something like Photoshop, you can compute the average luminance of the image and equate those. So that's already been done. So again, nice reason to use prepackaged stimuli rather than trying to make your own. Okay, so I'm going to go to, I don't need to do that. So I'm going to switch to CyclePy here. And as hopefully you've already explored CyclePy a little bit, CyclePy has the builder, which is the graphical interface, and then the coder, which is for actually entering Python code. We won't need to worry about the coder view. We'll just focus on using the builder view. And when you open it up, you have this top window which shows it's a tab with a trial. And here's a timeline in seconds, and it's blank. And then you have components that you can add to it, like text or images or sounds or keyboard responses. Down below, you can actually unpack a number of other types of things, many of which you won't need to use for our study, but there are things like you can play movie files, you can present these gratings, these sort of black and white bars that are useful in some studies, random moving dots if you want. You can even do things like draw simple shapes like squares and circles and that kind of thing. A lot of the response options here, well, the one that might be useful is a microphone if you're having people do vocal responses. Some of the other ones are sort of hard-coded for different commercially available response boxes. So there are various companies that will sell these button boxes that have really good timing and different customized layouts and that kind of thing. For today, we can basically get away with the favorites. And so that's the top part is this trial timeline. Then down at the bottom, you have the flow of your whole experiment. And right now, our whole experiment consists of one trial with nothing in it. So there's not really much to talk about. But we'll be building the experiment by adding components to the flow and then editing each of the individual components up here one at a time. All right, so we want to present a face. So the simplest thing to do is click on the image, and you get image properties for this image, and you can name it something. For starters, we can leave the defaults. As you start building your experiment, though, each of these has to be distinct. So if you only have one kind of trial, so in just backing up, what we're going to build for now is the simple upright inverted face experiment. And we're really just going to loop through trials where it presents one face, whether it's upright or inverted, and then goes and gets a response, presents another face, and so on. So we can just work with the one image here. But if you had trials that went over multiple things, so say you were doing a priming study where you're presenting a prime image and then a target image, then you would have two different things, and you can't call them both image because within the program that's going to make it confused, and for your brain it would probably also be confusing. So you might want to call them image 1 and image 2, or prime and target would be even more intuitive. The time, so the start time is time 0, so that means basically once this trial starts, the image comes on right away. If you wanted to delay that at all, you could delay the start time. And then by default, the duration is 1 second. For our face experiment, we'll go with half a second, 500 milliseconds, which is 0.5 seconds. Change that. And the image, the simplest way to do this is you can hard code an image name in there. And so I'm going to say, okay, I'm just going to copy the name of one of those image files and paste it in there. Position 00 is the center of the screen, but you can change that. So if you wanted stimuli to appear like in one corner, or say you wanted to present 4 different faces, one in each corner, you'd have to have 4 of these images in your timeline all starting at the same time, and then just hard code different locations for them on the screen. So you can do stuff like that. You can also specify the size of the image. Again, leaving it at the default is fine. These things are proportional. So right now this is saying, I believe, it's going to be 50% of the width of the screen and 50% of the height of the screen. So it'll scale the image to each one. So as long as all your image files are the same size to begin with, they'll all appear the same on the screen. That's another consideration. If you're getting images from different sources, you might have to manually crop them in Paint or something like that to make sure they're all the same size before you run your experiment. Orientation. In this case, as you saw, the inverted images are already inverted, so we don't have to worry about changing the orientation. But here you could actually rotate your stimuli by X number of degrees, so 45 degrees or whatever, if you wanted to. Opacity, you could make your images transparent, partly transparent if you wanted. And units we'll just leave as it is. Okay, so that's our image. And then we want to get a response from the subject as to whether the face is upright or inverted. And so we'll click on this response. And here we've got key response, start time. So here this is defining the time window where it's going to be listening for or watching for a response. And as you talked about in the tutorial, and as I mentioned today, human reaction times are typically no shorter than 200 milliseconds. So if somebody does respond within the first 200 milliseconds, you probably don't want to record that because it's probably some sort of false response or to the last stimulus or just they're like trigger happy or something. So we're going to set our minimum to be 0.2. And then the stop, if you leave it blank, it just waits until the end of the trial and we'll listen for a response all the way out. So in this case, that's what we want. And then down, force end of routine just basically means that it'll expire at some point. And in this case, that's going to be defined by the duration of our image here, which means that it'll only listen or watch for a response as long as that image is on, and then this trial is going to end. So there are a couple of ways we can get around that, but for now we'll just leave that as is. Then the allowed keys is where you specify which responses are acceptable responses. So it'll only record a response if it's one of these allowed keys. It gives you some defaults like yes and no, left and right, and space, where left here means the left arrow button. It doesn't mean they literally type in LEFT. And space is the space bar, as you might imagine. And notice that they're all in single quotes, and that's important. That's one of the little bits that you have to, that sort of carry over from the fact that it is under the hood written in Python. So that's the kind of error that's often bugs people, is that they'll just type something in without the quotes, or they'll open the quote and not close the quote, and then they get errors and that sort of thing. So you have to be really sort of mindful of that kind of thing. In this case, I'm going to remove all of those because the most intuitive response keys for up and inverted are the up and down arrow keys. So I'm going to find this as single quote up, single quote, comma, single quote down, single quote. And store last key is the default. You can do other things like first key, which means that if somebody pressed one and you wanted to catch like their intuitive response and not their corrected response, because they might make one response and then change it, you could do that. You could store all the keys, sort of thing. Store correct is if you want to also, so by default, CyclePy will record what the response was, but it can also compute for you whether it was correct or incorrect response, which saves you time and trying to figure that out later. So it's nice to do, and then the correct answer has to be one of those two options. So this is an upright stimulus, so the correct answer is up. And the other ones just leave as defaults. Okay. All right, so now we've got a trial, and hopefully I can run this and it actually works. So to run, you press the green run button, and I haven't saved this yet, so it wants me to save it. So that's fine. If you're following along, save it in the Faces Simple folder. The reason for that is that it's not going to find the image file unless the image file is in the same place as your program. So the other option, as I said before, is you can put the images or this whatever stimuli in a subfolder of your experiment folder. We're not going to, that's a little more complicated, so we're just not going to do that for now. And I'll call this Faces Simple. And then it prompts you, and this is the default for CyclePy, is to prompt you for a participant code. In general, it's good experimental practice not to use people's real names. For testing purposes, this will define how the log files, the output from this, are saved. For testing purposes, I usually just mash on the keyboard. All right. And so now it's waiting, it's actually waiting until I make a response. So press the up key, and then that's all the experiment was, so then it quits. And it gives you, and often it'll give you some errors. A lot of those errors or warnings are meaningless or inconsequential. So as long as your experiment looked like it ran, then you should be okay. All right. So that was the simplest experiment ever. Now, if you wanted to present all 6 stimuli, the way that's sort of easiest but dumbest to do it would just be to create a new trial. So I can say insert routine. So I can say insert a trial. And then I get this little dot. If you're looking down at the bottom in the flow section, I can say insert it basically before or after the existing trial. So I can create a new trial. But this is actually just a copy of the same one. So either one is just the same one. So it's just going to present the same stimulus twice. If I wanted to present a different stimulus, I could say insert routine and say new. Call it trial 2. And then tell it where to put it. I'm actually going to right click and remove this copy of the first trial. Right, so now up at the top you can see I've got a tab for trial and then a new tab for trial 2. And now I can add an image and a response. I'm not doing anything with these. Right, and so you could hard code each trial in sequence. Yeah.
If you copy the trial 1, will it maintain all the settings from trial 1 all the way across? So all you have to do is update the image name?
No, there's only one. It's like, it's not a copy so much as another pointer to the same trial.
So for each individual trial example that we set here, we're going to go back, remove the inputs like yes, no, left, right, space, hard code in, up, down, insert the picture, and adjust the timing for every individual trial.
You could. I'm showing you this, but this is actually not the way to do it efficiently. Yeah. This is sort of the intuitive way, if you've never thought about loops or computer programming, is just to create like one instance for each stimulus and do that. But it becomes very inefficient because then, say you want to change the duration of the stimulus, now you have to change each one, right, manually. Yeah.
So that was when he would use the Excel file to...
Yeah, exactly. So that's the next thing that we're going to get to. So I'm actually going to remove trial 2 here and insert what's called a loop. So now with the loop, again, you get this dot showing where do you want the loop to start. And then when I click before the trial, then I get another dot showing that it ends after the trial. If you had multiple segments, you can sort of arrange the loops in different ways. We can get to that eventually. And then you get loop properties. So name is now trials. We can call this like main loop. Loop type random, which means that, so this is going to read from the Excel file a bunch of different stimuli in random order. That's the default. That's what most experiments want. You could do sequential, you could do full random. The difference between random and full random is random isn't truly random because once you've used a stimulus, it's not going to reuse that stimulus. So it's increasingly less random the more stimuli you present. Full random means every time it runs a trial, it's drawing from the whole list. So you're going to get some, if you're only running, say, 6 trials and we have 6 stimuli, we might not see all 6 individual stimuli each time. We might duplicate some of them, which is, again, generally not what you want to do. Random is typically what you want. Is trials? Yes, is trials. Random seed, just leave blank. What that means is that on a computer, a random number generator requires a seed, which is like some number that it uses to generate random numbers. By default, it uses the clock, so it just looks at the clock of the computer, and whatever time it is currently, that's the random seed. That means that every time you run it, it'll be different. If you want a random order, but you want the same random order every time, then you can hard code a seed in there, and then it'll be a random sequence, but it'll be the same random sequence every time you run it. NREPS is the other one that usually you want to change to 1, because this means whatever the list of stimuli is that we give it, it's going to go through it NREP number of times. So in this case, with 6 stimuli, we'd actually end up with 30 trials if we were using 5 reps, which we don't want. Selected rows, again, is we're going to list all our stimuli in an Excel file. So if you wanted to select a subset of that file, you could specify it there. And then conditions is where we're going to load in the Excel file. So before we do this, we need to actually create the Excel file. For, yeah, it just takes the Excel file. I think. Okay. So in the Excel file, at a minimum, we need to list our stimuli. And where'd that go? Things open. There we go. This is simple. Okay. So while I'm here, so this is the directory with the 6 face images. But now you can see that because I saved my experiment here, I've got a couple of files. I've got SciExp, faces simple SciExp, which is my actual experiment file in CyclePy. Whenever you run, by default, it saves a copy of the experiment as it was run that time, called lastrun.py. These are, for the most part, useless, and you can just ignore them or delete them. And it also creates a data folder in which it stores the log files. We can look more at this later, but basically, you've got something. Remember, we just had 1 trial, so it says, my stimulus was of the category up, and here's, details about it, like my reaction time and the time that the experiment occurred and that kind of thing. So all your experimental output gets stored to one of these log files by default. All right, so, and this is a trick on a Mac, at least, is you can highlight the files and do Command-C, and then switch over to Excel and Command-V, and it'll paste in the file names. So do that. And you'll notice all the files end in .bmp because they're bitmap image types. You can have that in here, or you can sort of hard code it in your experiment. For now, it's easiest just to have it in the Excel file. The other thing is at the top of the Excel file here, I need to insert a row because I need a header that's going to be used in CyclePy. So we're going to call this row the stimulus. And so at a minimum, you have to specify the stimuli for it to read. But in this experiment, we have 2 different categories, and it would be nice in running our analysis if we just knew which category each stimulus was, upright or inverted. So we can say category, or maybe condition. These things are arbitrary, right? They're just labels for you. So first 3 are upright, and then the last 3 are inverted. So call them up and inv. Sorry, this isn't super clear, I realize. There we go. And then another thing, if we want to, again, code the correct, incorrect responses, we also want a column that tells it what the correct response would be for each trial. So call this core resp. And this is literally what the keys are going to be. So it's going to be up, 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 and then down, because it's the down arrow key. And then the last thing is, we won't be using this today, but it's a good exercise to do it, is put in the codes that we want to send to the EEG system. And so we can just call this EEG code, and we'll code the uprights as 1 and the inverts as 2. All right, and that's all we need. But again, what you put in here is up to you. You basically, for each row that you have a stimulus, you need to fill in all the other columns. But all of these columns can be used in your experiment. So if you want to include other information, like say, this is like gender, and we can say male, male, female, male. I think they're all males in this case, but for the purposes of illustration. And in your CyclePy experiment, if this information isn't used, that's fine. It just ignores it. It should copy it, though, into the log file. And so you might have other information you want to know about the stimulus for later analysis that goes in the log file. That's more for the behavioral analysis because, again, for the EEG analysis, you're relying on these EEG codes. So for EEG, it was actually relevant whether it was male or female. You'd want more than just 1 or 2. You'd want like 1 is upright male, 2 is upright female, 3 is inverted male, 4 is inverted female. Something like that. I'm going to delete that column. And then we save this in the default Excel workbook format. Just make sure you save it in the same folder as your experiment. Simple. All right. And faces dim list. You can call it whatever you want. All right. So we're going to switch back to CyclePy now. And remember, this is our loop properties. So now if we hit browse, we can find our Excel file and select that. And see, it reads right away that there's 6 conditions. So that's a number of rows, 4 parameters, number of columns, and then it tells you what the parameters, what the column names are. There. It's all good.
Will the parameters always read from the A row in Excel?
Yes. From the A column. Right. It's the columns in Excel that are lettered, and then the numbers are the rows.
But then it would read from the row overs, right?
It knows that the first row is the header.
Yeah, okay.
With the labels, and then every other row it assumes are trials. Yeah. Right, so here you can specify a subset of rows, and if you can see there, the first row is 0, not 1. Not sure about here is why it's not giving me the OK button. Oh, I bet it doesn't like the space in main loop, main underscore loop. That's why. Doesn't like spaces in the name. Okay.
The new version yells at you if you do that.
Ah, see? That's a useful feature. Okay, so now down at the bottom in the flow, you can see we've got our trial, but then it's superimposed this main loop that shows basically that it'll loop through trial as many times as it takes to get through that file. But now the other thing I need to change is go back to my image, because before I had hard-coded the image. That doesn't work now that we have the file. So we have to put in there the name of the column that specifies the image name, which is stimulus in the Excel file. So you want to say stimulus. I believe we think we need to say $ stimulus. And here, interestingly, it seems to have reset this. Oh, I'm in trial 2, darn it. Okay. So this is actually something to keep in mind. Remember I made trial 2 and then I deleted it from down in the flow, but it still exists as a thing that I could use in building my experiment, and I wasn't looking at there. So I'm going to get rid of trial 2. Here's trial 1. So here, that makes sense. Now I'm going to replace that with $ stimulus. So the $ basically tells it that this is a variable name and not to literally look for a file called stimulus. We've got our duration right. Yep, all good. That should be good. Okay. So now we've got that. We've still got our response, so that should be good. We've got our loop. And it crashed. Name error, stimulus is not defined. All right. Stimulus, looks like it's defined. Oh, the other thing, actually, I did screw up. This is probably not the problem, but here, constant, we actually want to set that every repeat. So that means it'll update every time it runs through this, as opposed to just picking one and then rolling with it. There we go. That was the problem. Okay. And now it's waiting for me to make a response. And then we're done. All right, so that's pretty good. The only thing that I would want differently is that the stimulus is on for fixed duration and then it goes off, but then it's waiting until I make a response to go on to the next trial. And in this experiment, that's not what I want. I'd rather it just sort of goes, and if we don't get responses on every trial, so be it. But otherwise, the experiment's going to take a really long time, and we're going to have variable interstimulus intervals, which might be a problem. And so the way to get around that is I just clicked on my key response thing, and for duration, I can specify a maximum duration there. And I'll say that's maybe 0.7, so 700 milliseconds. All right, I'm going to save that, run it. And see now I'm not pressing any buttons, but it's still proceeding. Done. All right. Any questions so far?
Will it record the miss as like an incorrect?
Yeah. Yeah. So if we go to the log file now, and see here, now that we have multiple subjects run with various garbagey names, it also stores the date and the time that you started running the experiment in the file names. So I can figure out the last one I ran, since I was using stupid names, was the one with the most recent timing. And also for each thing, it saves 3 files. It's the CSV that's the one that is most useful. That one will open in Excel. So here, basically, it doesn't say it's an incorrect response. It just tells you there's no response, which is actually important because there's a difference between not pressing a button and getting it wrong, right? So you can see here, this is stimulus that was presented, what the correct response was, what the condition was, some various sort of the sequence of stimuli, the date. It tells you the frame rate, so we're nominally 60 hertz. Participant name, experiment name, and then our response would have been in there. And since I didn't respond, I don't have any reaction times, but it would store those as well. Any other questions? Okay.
Sorry, I suppose one more question.
Mhm.
Because we're going to be working with the same 6 or so people, and if we input their name and session 2, will it just update that individual Excel file, or will it create a new Excel file for them?
I think it creates a new Excel file.
Okay.
Yeah. It might have that session information in the file name or something, or it might be in the Excel file. It doesn't really matter because it's certainly not going to overwrite the previous one because all the file names have the date, and because it's storing the date and the time. If you ran multiple sessions, you'd be able to figure out which trials were session 1 versus 2 from that information as well. And you can always merge those Excel files afterwards and have everything in one big file. Right? So just to show you, this is for the full set of phase stimuli that I have, what the Excel file looks like. So it's just basically a longer version of what you already saw. And again, it's just coding the phase image name, whether it's upright or inverted, what the correct response is, and what the EEG code is. So we've got all the upright ones and then all the inverted ones. But the other thing, going back, and I know there's not a lot of class time left, looking at this flow again, and this is, he showed this in the tutorial as well. Normally you don't want to just press go and have it start showing stimuli to your subject, because usually you want to sit the subject down, say, okay, just sit there, turn on the EEG, make sure their waves look good, start recording on the EEG system, and then get them to go. And ideally give them some standardized instructions first. So we can just insert routines to do that. So we can insert a new routine, call it instruct. I don't think I spelled that right, but that's okay. And then here for the instructions, you can make the instructions as like, do it in PowerPoint, save it as an image file, or you can just have the text here and say, welcome, press up arrow for right faces. And here the duration is set to 1 second. If you say no duration, it'll stay on the screen until this part of the routine ends. So we can actually define it based on the response, right? So it'll just sit there until they press the space bar or something like that. So to that end, I can say press space bar to start. Okay. And then add a response component. And here we'll say the allowed key is space. And again, start is 0 and duration is infinite, meaning wait until you actually record the spacebar press and then go on. Okay?
How did you get to the screen where you made the spacebar?
Oh, sorry. I just hit the key response one. And any of these, once you've built them, if you click on that in the timeline, it pops that back up. Yep. Right. So you've got your instructions. And so the only advantage of using PowerPoint to do this is it's a little easier in PowerPoint if you want to do things with layout or font size or like add an image or that sort of thing. You can control the font and all that stuff in CyclePy, but you probably already know how to do that in PowerPoint, and you probably don't already know how to do that in CyclePy. So it's just an expediency sort of thing. Oh, and by the way, when you're running a CyclePy experiment, if you hit the escape key, it'll bail out. It will, if it's in the middle of something, so if it's in the middle of a trial and it's waiting for a response, you'll have to press the response key before it'll bail out. Or if it's in the middle of presenting a stimulus, it'll wait till the stimulus is finished. So there might be a slight delay, but you can always get out that way. And that's really it, right? If one thing that's common in EEG experiments is you might want to build breaks in. So rather than just sort of burning through all the trials, we could say, okay, let's insert another routine. We'll call it break. Put it after the trial loop, and do something like add text and say, take a break, press space to continue. And again, infinite duration. Click on the little keyboard thingy, add a response where we're just looking for the space. And then we can insert trial. So I'm inserting a copy of trial over here, or another pointer to the same trial loop. Put a loop around that, like that. In loop 2. That's 1. And here you could either be using the same Excel file, or you could have a separate Excel file for each block, as you wanted. Right, and so now it'll run through the file once, basically for the first loop, give them a break, and then run through, in this implementation, it'll run through the same stimuli a second time. So if you want different stimuli in the different parts, you could either have separate Excel files, or remember in that loop, selected rows. So I could say like, pop up the syntax. I think it's like, and it starts at 0, not 1. So you could say 0 to 99 to run the first 100 stimuli in the first block, and then like 100 to 199 for the second block, and then everything's coming out of the same file, but so it's a little easier that way. Yeah. And that's pretty much as I think you need to know to get started programming your experiments. And then once you shouldn't start programming yet, obviously. We should design the experiment first and make sure everybody's on the same page. Once you start, it is the sort of thing where you just have to expect that there's going to be lots of iterations and lots of testing. Try and start small, right? So I started with one stimulus, made sure I could present that, then made an Excel file with 6 files and made sure it could run through that. Because if you start with 100 trials and 5 blocks and this sort of thing, and something doesn't work, it's a lot more work to figure out what's going wrong and then fix it across all the different components. Then start small, get everything worked out, and then build out. And then if you're doing stuff that is sort of beyond what's obvious here, you can always ask Liam, or failing that, me, and we can help you. Liam's used CyclePy a lot, so he's quite familiar with its vagaries. Questions? Yeah.
Sorry, just one more. Following the instructions queue, or prompt, sorry, before it launches into the trial, does it automatically put in a little bit of a buffer, or when they hit space, does it automatically pop up the face?
Yeah, when they hit space, it basically automatically pops up the space, yeah. So if you wanted a bit of a delay, you'd have to manually build that in.
Okay.
One way to do that, so if we look at the trial one, is the image. Rather than having start at 0, we could say start at 0.1, and then duration stays the same because that's not the end time, that's a duration. Right, so we'd still have a half-second stimulus, but there'd be a 100 millisecond buffer at the beginning before it presented. Yeah.
For those kinds of experiments, do you use a fixation clause? Because it's just one and it's in the middle, so it's kind of obvious? Or?
Yeah, it can be helpful. In this, where they're coming really quickly too, not so much of an issue. It doesn't hurt. If you've got longer delays between stimuli, it is helpful to just give people something to stare at, especially in EEG studies where we don't want them to move their eyes. So yeah, that's a good point. Thanks for bringing that up. The other thing I was just going to say is, here's very simple. We've got trial within a main loop. You could insert something like, feedback, say. So your loop could have more than one component in it. So if you wanted like the trial and then feedback that said, correct or incorrect, or if it was a multi-part thing like the priming study, right? So you present a prime stimulus and then a target stimulus. You could actually probably fit those within the same thing just by sort of saying, okay, there's an image on for 500 milliseconds, then the second image starts at 600 milliseconds, whatever. But you can, it's very modular, so you can build things out like that. All right, now I'm really done.